What is the topic today? Today's topic is, here you see I write CH3, and if this reacts with water, H2O, product would be the ethanol here, CH3, CH2, OH, which is coming from water, and another hydrogen is left, and this hydrogen will combine with chlorine to form hydrogen chloride. So this is a reaction, this is a nucleophilic substitution. Chlorine has been substituted or replaced. Another reaction I'm going to write here, CH3, CH2 and Cl, could be Cl, and this is with OH minus, alkali here, aqueous alkali, aqueous to be given here. And then the reaction will be similar, substitution reaction. You would get here CH3, CH2 and OH. This OH has substituted this chlorine, and you would get this time chloride, the halogen as halide ion. Certainly sodium hydroxide was there, or any other hydroxide was there. That means this contains a metal. The metal ion must be there with OH. OH cannot be alone. That metal ion combines with this chlorine and forms sodium chloride, or like this. So these two are substitution reaction. Now the question is, which of the reaction do you think is easier or more likely to happen? The second reaction is more likely to happen because here OH is a free ion. Okay, OH doesn't need to be formed. Okay, so OH is free. It is an ionic compound. Sodium hydroxide was there. Sodium was bonded with hydroxide. So ionic compound, when dissolved in water, they are already separate. So there's nothing to break the bond. There's no question about to break the bonds between sodium and hydroxide. It's already broken. So this can easily substitute this chloride, and this is easier. Okay, and for this is not the same fact. Here OH is not ready. Water means water is this. You first need to break the bonds, break the covalent bond that needs energy, and when you break the bond, then OH is formed. Then OH will substitute this chloride. This is why this reaction is faster and easier and needs less heat. And first reaction is reversible. You already got that this reaction you started, ethanol and hydrochloric acid. If you mix ethanol and hydrochloric acid, they react to give chloroalkane. And here we are getting ethanol from chloroalkane, which means the reactions are reversible. And this reaction is not reversible. This reaction goes to the completion because what is there? OH is free there. So these are two reactions, comparative two reactions. And another reaction, which is an elimination reaction. What does the elimination mean? Something is removed. Okay, something is removed. And this reaction, what I'm going to talk about, is very interesting and very important because the equation I write here, CH3, CH2 and Cl and OH, and this reaction gives CH2 and double bond CH2 and HCl. This is the reaction. I write here again OH. Then later OH and HCl will react to form water and chloride and chloride ion. So this is the first form. These two are first form, and then later form water and chloride ion. And there must be a metal. Then metal will form sodium chloride. And look at the reaction carefully and see how is the reaction peculiar. In this equation you get chloroethane reacting with hydroxide, and that is giving substitution reaction. Alcohol is the product, and in this equation you get the same thing. Here you get chloroalkane and reacting with OH, but this time you get alkene here, and with water and chloride formed in this reaction. So both the reagents are same in these two equations. Reagents are same, but the reactions are not same. They are the different products. So this is interesting thing, and this is very important for exam, especially in the exam. The difference caused by the condition, not caused by the reagents. In both the equation you get halogenoalkane, hydroxide, but basically the conditions are different. Conditions, this is aqueous. Okay, the first hydroxide is aqueous, which acting as a nucleophile. But this equation, in this equation, OH is not aqueous. When OH is not aqueous, this is somewhat OH is dissolved in alcohol or organic substance, okay, without water actually. OH is not having water, so this is dry or alcoholic OH. This is why you get the total reaction is different, elimination reaction you get here. And in this elimination reaction, I'm going to show again, if I write the displayed formula, the chloroalkane, and chloroalkane is reacting with what? With this hydrogen and chlorine. Look, chlorine from one of the carbon atom and hydrogen atom from the neighboring carbon atoms. These two combine and form hydrogen chloride. And this hydrogen chloride is here, hydrogen chloride, this hydrogen chloride gone. And then this hydrogen chloride will react with OH. Here OH is acting as a base. Here OH is, in this reaction, OH is acting as a base because that is extracting a hydrochloric acid or hydrogen chloride and neutralizing the hydrochloric acid. That means OH is a strong base, being a strong base, non-aqueous, neutralizing the hydrogen chloride, and this is why you get this reaction, this elimination reaction. But here the role of OH is different. If OH here in this equation or in this reaction nucleophile, and OH here in this reaction as a base, okay, base. So here this happens, the elimination reaction, and here this was a substitution reaction. I hope these things are clear. If this is the reactant, and if you add sodium hydroxide and heat this elimination reaction, here chlorine has two options. Chlorine gets two options. One, chlorine may take this hydrogen of this carbon to make double bond between these two carbon atoms. And if this happens, that chlorine takes this hydrogen to form hydrogen chloride and double bond forms between these two carbon atoms. Product after this hydrogen and chlorine gone, you would get this product is but1. But if this happens, that chlorine takes this hydrogen to combine with, then what would be the product? The product would be but2. Then you would get here double bond forms between these two. This is the interesting thing. When you get things with puzzle, then that is very important for the exam. So always remember, if you hit this substance with sodium hydroxide, okay, sodium hydroxide is a reagent, okay, what would be the products? So your job is now draw the products, possible products, and I'm giving you condition. This is aqueous, or another options here. When this is dry or alcoholic, you again heating sodium hydroxide with 2-chloropentane, okay, sodium 2-chloropentane, but alcoholic. So what would be the possible products? So now you draw.